I told you I'd make this video, so I'm going to make this video. We are going to build a 3D representation of the electric field all around this charge rod. So let's just review quickly, because I already made a video where I just calculate the electric field at different places and I show one thing. But I want to display the electric field in a lot of different places. Okay, so if I have a charge rod, in this case it's a length L, a charge Q, and I want to find the electric field right here. Well, I don't have an expression for the electric field due to a rod. I have the electric field due to a point charge. So if I have some point charge Q right here and located by the vector RQ, and I want to find the electric field at some observation location RO, then I can find the vector R from Q to RO, and that's just going to be RO minus RQ. And then the electric field due to point charge would be some constant, 1 over 4 pi epsilon naught, times the charge Q divided by the magnitude of that vector R, multiplied by a unit vector in that direction. That unit vector you have to get this as a vector. And if you don't have this as a vector, this thing's not going to work. So you have to use this form of the electric field. So over here, what I'm going to do is to break this into pieces. Something like that. And then I can take each piece, that's the observation location. I can take this as my charge location. That'd be like this, RQ. And then this would be R. So I can do the exact same problem. And I can find the electric field, and it would look like this. I'll call it DE, because it's just the electric field due to this little piece. And then I can do it to the next piece and find DE, and the next piece and find DE. And then the total electric field will just be the sum of all the individual electric pieces. And so I can find that. Now, in this case, that's 1, 2, 3, 4, 5, 6, 7, 8. I can break this into 8 pieces. But if I build this in Python, I could do 8 pieces, 100 pieces. I could do whatever you want. And I've already done this. I'm going to show you the code I have, and then we're going to modify it. Because what I want to do is to display the electric field at regular intervals around the thing. Okay, so let's switch over to Python. And this is the code that I've already made, and I already have a video for it. And I promise you I'm going to link it down below. I'm not going to forget. Okay, so here is the code. Let's just go over this really quickly, because I am going to change it to make it better. It's going to be awesome. Okay. So up here we have the constant K. That's the 1 over 4 pi epsilon naught. Q, L. If we're doing this numerically, breaking this into a finite number of pieces, I can't get an analytical expression for the electric field. I need a numerical vector value. So I have to have charges, I have to have lengths, I have to have everything in actual numbers. And then here's N is the number of pieces I break the rod into. DQ is the charge for each one of these little pieces right there. Okay. And then DY is the distance between those pieces. So it's just, what my step size is. So right here, this is the location that I want to find. The observation location is not a big deal. It can be wherever you want. This is my total electric field. I start with 0 because, let me make that a little bigger. Because I'm going to add things to that, but I have to have something to add to it. It has to be a vector to add to it. So I have to start with vector 0. And then this is the location of my first charge. So if you'll notice, down here, I have the rod has a length of L centered at the origin. So down here, the bottom of the rod is negative L over 2. But I want to go up to the center, and so that would be, I have to shift up. dy is the width, the diameter of that sphere, and I divide that by 2 to get in the middle. So if you break this into 100 points, it doesn't really matter, but I'm going to leave it there anyway. And then I put a sphere there, right there. That's that sphere right there. And then I go through and just keep moving up until I get to the top, and I make new spheres. And I also calculate the electric field, so I calculate the value R, I calculate DE, I calculate E, and then everything's good. So, but I want to do a couple things. One, I want to break this into 2 parts. The first part, I'm just going to make the rod as an object. I never actually made, I drew spheres there, but I couldn't reference them again because they weren't actually there. It's just, I didn't give them a name. I didn't give them anything like that. Okay, so the first thing, let's just start deleting stuff, because what the heck, right? I'm going to keep that there. I'm going to keep that there. let's delete this stuff. E scale, I'll probably need that. Let's just delete this. It's just making me not happy. Let's delete that. And I don't need sphere. I do need an observation location. Let's just keep that there for right now. Okay, so let's say, let's put a little thing here. Make rod. So I'm going to make the rod. The first thing I'm going to do is to do this. RQ, I'm going to keep that. That's the location of the first object. And then I'm going to say this. Charges. This is a little weird. Equals square bracket, sphere, position equals RQ, radius equals, let's see, I did over here, L divided by 40 I think would work well. We can change it up. And let's give it, this, we have this cyan, so let's keep it at cyan. Color equals color dot cyan. I'm going to add another property to this sphere. You can add extra properties. I'm going to say Q equals DQ. Yeah, that's what I called it there. Okay, so now I have a list of things, and I have one object in that list. So I can't print the list, but let me show you another example of a list. I'm not gonna. I have another video down below that goes over lists. So I don't want to go into I want to get this done, and then if we want to talk about lists, we can talk about lists later. Okay, so now over here, I don't need this line because I already added that first sphere into my list of charges. But having a list allows me to go back and look at individual pieces. So now I can do this again. I can still do this. I don't need to calculate. I'm not going to calculate the electric field. So let's just get rid of that. I'm just making the spheres. So I do want to calculate RQ, and I do want a new sphere, but I want that to add it to the list, charges. So I'm going to say charges equals charges plus this item, and that should be 40. Not 240, 40. Color cyan, and I'm going to give it the charge also Q. And yes, they all have the same charge, and I don't really need to do that, but I just like to do that. It just makes me feel like a better person. Does that make sense? Okay, then I need to, yeah, I think that's it. So let's just run this. And there made my spheres. Can you see that? I'm sorry. Yeah, you can see most of it. I want to keep my expressions up there because I think it's fun. Okay, so I have that. Now let me just show you how that works. So since it's a list and it's only 10 items, I can do the following. Let's say print charges 3.pos. So charges 3 is a sphere. It's the fourth item in that list, and it has a position. I can indeed print that out. And see, there it is. So they are things that I can reference, and that's kind of cool. Okay, so I have the charges. I don't even know why I have print RQ, just delete that. Okay, so the next thing I want to do, and I can change this to 100 if I want to. It doesn't really matter. See, now that looks like a real rod. They're actually spheres and they overlap a little bit, but I don't want to make them too skinny or make the whole rod skinny. I don't want to, you could not even draw the spheres, but I like to draw the spheres. So just let me do it the way I like it. And please don't stop me. Okay, so now I'm going to move around and find the electric field. So I don't want to have to rewrite the code for that. So I'm going to use a function of the electric field. So I'm going to define a function. And again, I will include a link down below for introduction to functions. I promise you, and if I forget, please comment below. So let's call this function E. And I want to send it two parameters. I want to send it the observation location and this list of charges. And this, I'm using this as a global variable, a global list, which is a bad idea. But I like to do bad ideas because I'm a bad person. So let's call the observation location ROB for instead of just RO. But then we'll call the charges. That's a list. So I'm going to send it two things: where I want the electric field and what is my charges. And I wouldn't even have to do that, but I did. Okay, so now I'm going to calculate the electric field at the location ROB, which could be anywhere. The first thing I need is the base electric field. So I'm going to say ET for total is vector 0, 0, 0. Now I can calculate the electric field due to each piece and add it to that. So here's the fun part. For charge in charges. So this goes through the list charge, and for each element, it calls it the word charge. So if I use charge down below, it's an element in there. Let's go through each one. So the first thing I want to do is to calculate R. So R is going to be equal to R OBS minus charge.pos. And see, that's why I like calling the list charges, because it's a list of charges, and then charge is the thing in there. But you could call it whatever you want. I just think that's cool. Now I can calculate the electric field due to the piece. dE equals K, which I'm calling 1 over 4 pi epsilon naught, times the charge, which is going to be charge.q. It's the q component of that. If you did dq, that's cool too. Now I need to multiply it by the unit vector r, so that's going to be norm r. I need to divide it by the magnitude, mag r squared. So that's my electric field. Now I need to add that to my total. ET equals ET plus DE, and that's it. I'm done with the function, and I'm going to return the value ET. So let's try this out. Let's say print. See, I don't even have to do this. I can say E equals E, and I'm going to use the observation location up here, RO. So I'm just going to say RO charges. And let's give it a units, newtons per coulomb. Let's see if it works. And it didn't. RBO, see, it's ROB. That's my fault. The computers just keep me honest. So it looks like it's working, and so that's really cool. So now I can use that. I can just call E, put in my value, find the location, the value of the charge. Okay, so now we have that. What I want to do, I'm going to do one more thing. I'm going to say E scale equals 10 to the negative 6. I think that's what I used before. So what I'm going to do is to move my observation location around and just calculate the electric field and put an arrow there to represent the electric field. So am I still in the screen? Let's see. Yeah, let's scroll this up a little bit. Okay. So let's start with, I want to pick a step size. So I'm going to say this. I'm going to pick step X, and that's, instead of dx, I want to use dx. I used dy already. It's going to be 0.2 times L. That's just how big of a step do I want to make for where I calculate my electric fields. And then I can do step Y equals 0.2 times L. And then I need a starting location, so I'm going to say RO equals vector. I'm just going to start at step X 0, 0. So it's going to be off to the side of, I don't want to be right on the rod because the electric field is infinite there. I want to start off to the side, and then I'm going to move up. So let's say I want to move that position up. So I'm going to say while RO.Y is less than, let's say 0.8 times L, right? So all the way to the top of the rod would be 0.5 L, but I want to go a little bit further so we can see what the electric field looks like up there. So while that R value is less than that, what I'm going to do is to calculate the electric field. Well, I don't even have to do that. I'm just going to draw an arrow. I'm going to say, I'm not going to give it a name. I'm just going to say arrow. The position is RO. The axis is going to be equal to E scale times E RO charges. So that function is in my arrow, right? That's going to go ahead and go through all those pieces and calculate the electric field right there in that thing. And then I'm going to give it a color. Color equals color dot yellow. And now what I want to do is move up one step. So I'm going to say RO equals RO plus vector 0 step Y 0. Let's run this and see if it actually runs. Check that out. Okay, I'm going to move my thing down here. No, not that. Move this down here. Okay. So they're still a little bit big. Let's just make this 10 to the negative 7th for the scale and run it again. That's a little too small. Let's make it twice. Let's try 2. Yeah, that's actually not too bad. Okay, I'm pretty happy with that. Okay, so let's do this. I want to go actually a little bit higher. So let's just go to L. Let's just say 1L. Okay, so there's my, you can see the electric field starts getting really small up there. Now I want to go back over here and go down. So let's just do this. This is not necessarily the best way to do it. I actually could do this. I could say, I could start with RO at negative L. Right, I'm starting way down there and then I'm going to move up. I think that'll work. And then if I click run, check that out. That's pretty cool. Okay, now I want to do it again, but now I'm gonna move my X, my step X over here. So let's just copy this. This isn't necessarily, you could do a nested loop. You definitely could, but I'm not going to. I'm just gonna copy this code and paste it again. And I'm going to go up here and say RO equals vector 2 times step X, negative L. 0. So then it's going to start over to the side a little bit and it's going to do it again. Let's see what that looks like. Okay, so my vectors are a little overlapping. I guess I can make my scale smaller, or I can make my step size bigger. Let's make the step size a little bit bigger. Let's make these both I'm going to make this one 0.3. Step X is 0.3. Okay, I'm pretty happy with that. I'm pretty happy. Now, if I want to, I could repeat this at different angles around there in the z-axis. So let's see if we can do that, just to make it fully three-dimensional. So I'm going to go up here and say theta equals 0, d theta, now you gotta spell it right, theta equals 2 times pi divided by, let's say 8. So it'll go 8 times around. And then I will say, while theta is less than 2 times pi, do the following. I'm going to put this over here. And then I'm going to indent this. I'm going to indent this. I'm going to indent that. I'm going to indent this. I'm going to indent that. Indent, indent. And then I need to down here say I need to increase my theta. So theta equals theta plus d theta. Spell it right. So now up here, I have to think, if you look at this from looking down, this is the y-axis. So I'm looking down the y-axis. So I want to pick my thing in the xz plane, So if that's the case, I can say, let's do this. Let's say, yeah. Let's say, I'm going to say R equals 2 times step X. No. 1 times step X. Let's just use step X. Okay. So over here, my starting vector, I want to multiply, I want to say this. Step X times the cosine of theta, and then this will be step X times the sine of theta. So it's a projection into the xy plane. Let's see, cosine of theta is, that's right, that'll be right. And then I'm going to do the same thing down here. I'm going to say 2 times step X times cosine of theta, and then 2 times step X times sine of theta. I think that will work. I don't know. Let's just run it. Aha, it worked. Okay. So I can rotate this around. Come on, man. Let's see, let's make this bigger. Okay, make the whole thing bigger. So there you go. There's my electric field. Again, we're in the region of making art, not anything else. But here's your screenshot right here. You need a good thumbnail. So let's see. I'm gonna do it like this. There, that was a thumbnail. Okay, I'm pretty happy with this. Look at that. Okay, so the electric field due to a charged rod. I can't stop moving around. You gotta play with this code. change it up, do some fun things with it. I'm going to give you the code. Like I said, I'm going to give you a video on the previous electric field due to a charge rod. I'm going to give you a video on functions. I'm going to give you a video on lists. Now you're all set. Okay, that's it.